Review of linear equation. A linear equation is an algebraic equation where every variable has a power of 1, meaning it's not raised to any other power like squares or cubes or under any radical signs like square roots. When graphed, a linear equation with two variables will always form a straight line. So this is an example of the graph of a linear equation. We have forms of linear equation. Linear equations can be written in various forms, with the most common being the slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept, where the line crosses the y-axis. Example, 2x plus 3y equals 6 is a linear equation in general form. Here, a equals 2, b equals 3, and c is equal to 6. Let's say you have negative x plus 5y equals negative 10 is another example with a equals negative 1, b equals 5, and c equals negative 10. Second, slope-intercept form. Y equals mx plus b, where m is the slope and b is the y-intercept, where the line crosses the y-axis. The example y equals x plus 6. So here's the graph of the equation y is equal to x plus 6, where m is the slope, and here y equals mx plus b, m is equal to 1, and the y-intercept is 6. As you can see, the y-intercept is 6, meaning the point is 0, comma 6. And this point 0, comma 6 passes through or crosses the y-axis at point 0, comma 6. Another form is the general form. We have ax plus by plus c equals 0, where a, b, and c are constants. Take note that a, b, and c is an element of R. X and y are variables. A and b are not both 0. Example, 2x plus 3y plus 4 equals 0. And again, since that is a general form of a linear equation, the graph also align. How about the point slope form? Y minus y sub 1 is equal to m times the quantity of x minus x sub 1, where m is the slope and x sub 1 and y sub 1 is a point on the line. Here's the illustration for the point slope form. As you can see, the graph leans to the left, meaning to say that the slope is negative. Again, if the slope is negative, the line leans to the left. Forms of the equation of a line, we have the slope-intercept, y equals mx plus b, where m is the slope, b is the y-intercept. Point slope, we have y minus y sub 1 equals m times the quantity of x minus x sub 1. M is the slope, and x sub 1 and y sub 1 is a point on the line. The standard form, ax plus by equals c. A is positive, of course. Then intercept form, x over a plus y over b equals 1. A is the x-intercept, b is the y-intercept. Take note, when you say intercept, the point is located in the x and y axis. The vertical, we have x equals a. The vertical line with a as the x-intercept. The horizontal, y equals b. Horizontal line with b as the y-intercept. So these are the different forms of the equation of a line. The key characteristics of linear equations. No exponents. Variables are not raised to any power other than 1. Example, x, y, not x squared, y cubed. Again, no exponents. raised to any power other than 1. No roots. Variables are not under square root or other root signs. Third, straight line. When graph a linear equation with two variables, will form a straight line in the coordinate plane. It can be horizontal, it can be vertical, or it can be leans to the left or leans to the right. You have to take note for the slope of the line leans to the right. That is a positive slope. If the line leans to the left, that is a negative slope. And if that is a vertical line, undefined slope. And if the line is horizontal, the slope is equal to 0. For consistent and inconsistent system, so we have first consistent independent, meaning we have one solution. As you can see here in the graph, we only have one point of intersection. The second illustration is called consistent dependent. Infinite solution, same line. So two lines have the same graph. The third one is inconsistent. No solution. As you can see here, two lines are parallel because there is no intersection or there is no solution. For computer engineering students, linear algebra is more than just an abstract course. It's the mathematical backbone of core disciplines like digital signal processing, control systems, circuit analysis, machine learning, and computer graphics. Whether solving Kirchhoff's laws using matrix methods, modeling state space, dynamics for controls, or manipulating vectors in neutral networks, the principles of vectors, matrices, eigenvalues, and transformations. So our next topic is solving systems of linear equations. A system of linear equations in two variables is a set of two or more linear equations that share the same two variables. The solution to such a system is the set of values, the ordered pair x, y, that satisfies all equations simultaneously. These systems can be solved using various methods, including graphing, substitution, or elimination. So this is our reference for the topic. Example. Another example is the systems of equation 3x minus 2y equals 5 and x plus 2y equals 3. So we will apply the other method, and that is called elimination method. Elimination. Elimination method. So given 3x minus 2y equals 5, that is our equation number 1, and x plus 2y equals 3. That is our equation number 2. So this is our systems. Then again, I told you we will use the elimination method. Since the y terms in both equations are opposites, negative y and positive 2y, that makes elimination quick. So add equation 1 and equation 2. We have 3x minus 2y equals 5 and x plus 2y equals 3. Again, because negative 2y and positive 2y are opposites. Then we will simply eliminate these variables. We have 4x equals plus 0y rather equals 8. Since this is 0y, the equation is 4x is equal to 8. Then divide both sides by 4. 4x over 4 is equal to 8 over 4. Then divide or cancel out. X is equal to 2. Therefore, we have the value of x which is equal to 2. Then to solve for y, to solve for y, what are we going to do? We will substitute the value x equals 2 to any of the equation. say we have 3x minus, say we have 3x minus 2y equals 5. Substitute x equals 2. We have 3 times 2 minus 2y equals 5. Then 6 minus 2y equals 5. Then negative 2y is equal to 5 minus 6. Subtraction property of equality. Then negative 2y is equal to negative 1. Then divide both sides by negative 2, negative 2. Cancel out negative 2. We have y is equal to, cancel the negative sign here, 1 half. Therefore, we have uh, y value which is equal to 1 half. So our solution is 2 comma 1 half. Okay? Now, to check if we have the same answer for the second equation, let's say x plus 2y equals 3. Then 2 plus 2y equals 3. Then 2y is equal to 3 minus 2. Then y is equal 2y is equal to 1. Divide both sides by 2. So we have the same answer, y is equal to 1 half. Okay? So it gives the same result, whatever, because that is systems of linear equation. To check, no, substitute the values 2 comma 1 half to any of the equation. Let's say 3x minus 2y equals 5. Then 3 times 2 minus 2 times, what's the value of y? The value of y is 1 half. That is equal to 5. Then 3 multiplied by 2 is 6 minus, this is cancelled out, 1 equals 5. Then what is 6 minus 5? Therefore, 5 is equal to 5. How about in the other equation or the second equation? That is x plus 2y equals 3. Then substitute 2 to x. We have 2 plus 2 times. Then y is 1 half. 1 half here equals 3. Then 2 plus cancel out 2 plus 1 is equal to 3. Therefore, 3 is equal to 3. Now, as you can see, both equations satisfies 2 comma 1 half. Then, in graphing, this is the graph. 3x minus 2y equals 5 and x plus 2y equals 3. As you can see, their intersection is 2 comma 0.5 or 2 and 1